In 2022, the James Webb Space Telescope pointed at a tiny patch of sky, a region so small it would be covered by a single grain of sand held at arm's length. What it found inside that patch of darkness was not supposed to exist, not by any known law of physics, not by any accepted model of how the universe was built. Dozens of fully formed Milky Way-scale galaxies, massive, ancient, complete, sitting inside a universe that was only 500 million years old. The models didn't fail. They shattered. Welcome to the Heriton Inc. archives. This channel exists for one purpose: to document what official narratives leave out, not to fabricate, not to sensationalize, to follow the data wherever it leads, no matter how uncomfortable the destination. Today's file, JWST Deep 001, codename the Little Red Dots. The official story, as presented by the scientific establishment, is clean and reassuring. Astronomers detected anomalous bright objects in deep field imagery. Upon further analysis, they revised their interpretation. These weren't impossible galaxies. They were something called black hole stars, exotic, novel, but safely explainable. The headline rewrote itself. The alarm bells were muted. Scientists nodded. But here is what the press release didn't say. Before the revision, the raw data implied something that directly challenged the foundational timeline of all known cosmology. And the revision? It happened quietly, quickly, without the panic the original discovery warranted. We are going to go through it, all of it. The official story. Let's start with what we know, what is verifiably, undeniably true. The James Webb Space Telescope is not a piece of science fiction. It is 6.5 meters of gold-coated beryllium mirrors, launched on December 25, 2021, and positioned at the second Lagrange point, roughly 1.5 million kilometers from Earth. Its primary mission: to see farther back in time than any instrument ever built by human hands. Because of how light works, because light travels at a finite speed, looking deeper into space is identical to looking deeper into the past. When JWST observes an object 13 billion light-years away, it is not seeing that object as it is now. It is seeing it as it was 13 billion years ago. It is, in a very literal sense, a time machine, pointed at the origin of everything. The current scientific consensus places the age of the universe at approximately 13.8 billion years. This number is not arbitrary. It is derived from multiple independent lines of evidence. The cosmic microwave background radiation, the faint thermal echo of the Big Bang itself, the observed expansion rate of the universe, known as the Hubble constant, the abundance of primordial elements like hydrogen and helium, and the redshift measurements of the most distant known objects. These lines of evidence have been calibrated, cross-checked, and verified over decades by independent teams across dozens of countries. The age of 13.8 billion years is as settled as anything in modern science. Now, the Big Bang model, more precisely, the Lambda CDM model, also makes very specific predictions about how structure forms after that initial event. In the beginning, the universe was an almost perfectly uniform plasma of hydrogen and helium. Then, over hundreds of millions of years, gravity pulled those gases together into the first stars. Those first stars, massive, short-lived, burning at temperatures we can barely simulate, eventually collapsed, seeding the interstellar medium with heavier elements. From those scattered seeds, second-generation stars formed, then third, and slowly, over vast timescales measured in hundreds of millions to billions of years, Small galaxies formed, merged, consumed one another, and grew. The key word is slowly. According to Lambda CDM, a galaxy the size of our Milky Way, containing roughly 200 to 400 billion stars, wrapped in a dark matter halo spanning hundreds of thousands of light years, should take well over 1 billion years to assemble. The physics is not ambiguous on this point. You need time for gas to cool. You need time for density fluctuations to amplify. You need time for gravitational collapse to proceed across galactic scales. When JWST first began transmitting data back to Earth, the scientific community was expecting to find exactly what the model predicted. Small, irregular, turbulent proto-galaxies in the early universe. Messy, infant structures. Nothing polished, nothing massive, nothing complete. That is not what they found. The data doesn't lie. Let's talk about what the telescope actually saw, and why the people analyzing the data went very quiet for a very long time. In JWST's first deep field images, cataloged in late 2022 and early 2023, researchers identified a population of compact, faint red objects. They were nicknamed, with almost deliberate casualness, little red dots. The name sounds harmless. It sounds like a minor footnote. It is not. These objects were identified at redshifts between 4 and 9. For context, a redshift of 9 corresponds to a look-back time of approximately 13.2 billion years. That means JWST was observing these objects when the universe was less than 600 million years old. Now, here is where the mathematics becomes a problem. The stellar mass estimates for these objects, derived from their luminosity, spectral energy distribution, and redshift, were staggering. Some of these little red dots appeared to contain stellar masses equivalent to 10 billion solar masses. That is 10 billion times the mass of our Sun, packed into structures already visible, already luminous, already organized, in a universe that was not even 500 million years old. To put that in perspective, astronomers had previously calculated that the total stellar mass density in the universe at that cosmic epoch should be at least 10 times lower than what JWST was seeing. Some independent calculations suggested the discrepancy was as large as a factor of 100. 100 times more stars than should exist. This is not a rounding error. This is not a calibration artifact. Researchers from the University of Texas, from Edinburgh, from Swinburne University of Technology, from institutions across 3 continents, all ran independent analyses and arrived at the same uncomfortable answer. These objects, if they were what they appeared to be, were physically impossible under the standard model of cosmology. Dr. Ivo Labbé of Swinburne University was among the first to publish on the anomaly. His team's 2023 paper, which appeared in the journal Nature, stated, in the careful, measured language of peer review, that these massive early galaxies represented, quote, a tension with standard cosmological models that is difficult to resolve. In scientific language, difficult to resolve is the equivalent of screaming. Then came the revision. By 2024 and into 2025, a new hypothesis emerged. A subset of astronomers proposed that the little red dots were not, in fact, mature galaxies at all. Instead, they were a proposed new class of object, extremely massive black holes, potentially millions to billions of times the mass of our Sun, wrapped in dense cocoons of gas and dust. The light in this model was not coming primarily from trillions of stars. It was coming from superheated material falling into a voracious black hole, a phenomenon called an active galactic nucleus, or AGN. These objects were given a new name, black hole stars, or more formally, direct collapse black holes. The headline changed. The crisis appeared to dissipate. Problem solved. Move along. But here's the anomaly that did not get a press release. If these objects are powered by supermassive black holes at a redshift of 9, in a universe less than 600 million years old, the problem does not disappear. It migrates. Because those black holes must also have a formation pathway. They must also have grown from something. The current record for the earliest confirmed supermassive black hole prior to JWST was at a redshift of 7.6, a black hole of roughly 1.6 billion solar masses, already theoretically difficult to explain, already straining the models. JWST's little red dots push the problem back another 300 million years, into an epoch where, according to Lambda CDM, not even the first generation of stars should have had time to complete their full life cycles. The seeds of those black holes, the stellar mass black holes that would theoretically need to merge and accrete for hundreds of millions of years to reach supermassive scale, may not have had time to be born. The rewrite did not solve the anomaly. It relocated it to a place with fewer journalists watching. What if the clock is wrong? Here is where we leave the domain of established consensus and enter the territory of documented scientific controversy, independent research, and what some cosmologists, speaking in the margins of conferences, have described as a crisis we are not yet ready to publicly name. This is a hypothesis. It is not presented as fact, but it is built entirely on real data, real anomalies, and real scientific papers that exist in the public record. What if the universe is older than 13.8 billion years? This is not a fringe question. It has been asked in peer-reviewed literature by researchers with legitimate credentials. In 2023, Rajendra Gupta of the University of Ottawa published a paper proposing that the universe could be as old as 26.7 billion years, nearly twice the current accepted figure. His methodology combined a modified cosmological model with alternative interpretations of the Hubble constant. He was not the last. The Hubble constant itself is in crisis. This is not a conspiracy. It is called the Hubble tension, and it is one of the most actively debated problems in modern physics. Two independent methods of measuring the universe's expansion rate, one based on the cosmic microwave background, and one based on observations of Cepheid variable stars and Type 1a supernovae, yield answers that do not agree. The discrepancy is roughly 8 to 10%. At cosmological scales, that is not a minor rounding error. That is a structural fault in the foundation of the standard model. Now consider this. If the expansion rate used to derive the age of the universe is even slightly miscalibrated, if the true Hubble constant is somewhat lower than the current estimate, the implied age of the universe expands. The timeline stretches, and suddenly, objects that appeared impossibly old begin to have just barely enough time to form. The little red dots stop being impossible. They become expected. This is not comfort. This is the more terrifying option. Because if the cosmological timeline is wrong, even by a few 100 million years, then every textbook, every museum display, every confident declaration from every institution about the age and structure of reality is built on a miscalibrated ruler. Not a lie, not necessarily a conspiracy, a mistake, a systematic error embedded so deeply in the scaffolding of modern cosmology that correcting it would require dismantling frameworks that have defined institutional science for half a century. And here's the darker hypothesis, the one spoken in the margins. Institutional science is not a neutral recorder of data. It is a human system, governed by funding cycles, career incentives, peer review gatekeeping, and institutional prestige. When a dataset arrives that threatens foundational assumptions, the statistical pressure, not from any shadowy cabal, but from the simple mechanics of how knowledge is produced and rewarded, pushes strongly toward the interpretation that preserves the existing framework. Independent researchers have flagged that the reinterpretation of the little red dots as direct collapse black holes, while scientifically plausible, conveniently eliminates the most destabilizing implication of the raw data, that the universe's structure does not fit its supposed age. The revision did not emerge from one bombshell paper with overwhelming evidence. It emerged gradually, across multiple teams, each proposing slightly different models, until the cumulative weight of alternative explanations made the anomaly feel resolved, without any single piece of evidence definitively resolving it. No data was retracted, no observation was disproven. The raw images still show what they show. The stellar mass estimates were not declared wrong. They were declared uncertain, complex, and open to reinterpretation. In science, that is a legitimate position, but it is also, critically, a position that can be adopted without ever looking directly at the hardest question. What are they, really? Here's the question that lingers at the edge of this entire investigation. If these objects are supermassive black holes dressed in gas, they represent an entirely new class of cosmic object, never predicted by any model before JWST. Objects of extraordinary mass, extraordinary energy output, appearing at epochs that our best physics says should be nearly empty of complexity. Whether they are galaxies that shouldn't exist or black holes that couldn't have grown in time, the answer to the same disturbing question remains the same. Something was there, earlier than anything should have been, and we are only now, with our most powerful instrument, beginning to see it. The universe either broke our timeline, or our timeline was always wrong. Both answers are terrifying, for exactly the same reason. The file remains open. We do not tell you what to believe. We present the data. We present the anomalies. We present the questions that the official narrative does not pause long enough to fully ask. The little red dots are still up there. JWST is still transmitting. New spectroscopic confirmations are still being processed in laboratories across the world. Each new data set will either tighten the anomaly or reveal a new layer beneath it. This story is not finished. The file is not closed. What we leave you with tonight is simple. The most advanced telescope ever built by our species pointed at the oldest light in the universe and found something that the existing model of reality did not predict and has not yet fully explained. Sleep on that. If you want to be here when the next file opens, you know what to do. Subscribe before the feed goes dark. 3I Atlas.